in the online batch, we are yet to discuss about linear regression lab practical, right? For the online batch. For the offline batch, we have already discussed the linear up to linear regression, but in online batch, we are yet to discuss lab 4 topic, right? But today, yes, lab 4 is remaining. Today, what we'll do, we'll first discuss the lab 5 assignment that we have today, that we are supposed to perform today. Then I'll create a different Google Meet link where the online batch students can join. Those who are in the online batch, they can join there, and we'll discuss the lab 4 there. Okay. So right now we'll start with the discussion of lab 5, and after some time we'll start with the discussion of lab 4 for the online batch. Okay. For those in the online batch for whom it is remaining, right? Is it clear to everyone? Okay. So in today's lab, we are going to perform implementation on decision tree classifier. So based on, can you tell me what are the different attribute selection method in decision tree classifier? Okay, voice is breaking. Is it? Is everyone facing this issue? It is clear for others? Okay. All right. So I think Ronak, check your internet connection maybe. All right. So in today's lab, what we'll be discussing is decision tree classifier we'll be discussing, and I'll be sharing the lab 5 assignment in a short while. Yes, information gain, Gini index, and gain ratio. Gain ratio, information gain, and Gini index. These are the 3 attribute selection methods on which we'll be performing our yes, entropy. Information gain refers to entropy, right? So we'll be discussing about these 3. First of all, we'll be discussing about in the implementation part. We'll be performing implementation on Gini index and entropy. So if you right now I'm opening the lab file assignment that I'll be sharing with you. So you have to recall all the. So what you have to do in today's lab session is, I have given already this data set. So here the data set is present. For this, first you try to create a decision tree classifier based on information gain. Okay. So you already know how to create a decision tree classifier based on information gain. What are the steps that you will follow? What are the steps that you'll be following in order to create a decision tree for information gain? So first step that you'll be doing is, you'll be calculating the entropy of the system, right? Entropy of the system that you have. Yes, entropy of the system, right, Priyank? You'll be calculating the entropy of the system. Later, you will be calculating the information gain from different attributes. Yes. So for example, here how many attributes do we have? We have 4 attributes here: outlook, temperature, humidity, and wind. Okay, we have 4 attributes. So what you will do, you will calculate the information gain for all the 4 attributes, and whichever attribute gives maximum information, that will be placed in our root node. That is the idea about ID3 algorithm. So ID3 algorithm uses entropy as a measure to perform attribute selection method, right? That is what you will be doing. So here in the file already I have given an example and how to calculate. For outlook I have given. So for rest of the attributes you have to calculate by yourself, and similarly you have to create branches by yourself. This is for your own understanding that you have to do, right? So in the implementation part, and the second implementation that we have is for Gini index. Okay, so we have in using sklearn, we are trying to perform the implementation using scikit-learn library. In this library we have 2 criterions, Gini index and entropy. And default is Gini index. So default, if you do not give any criterion to the decision tree classifier, it will automatically take Gini index as the default one, right, to create a decision tree. So another example that we have is using the Gini index that we have created. And if you recall, what was in Gini index? We were creating binary splits. Binary splits were being created in the case of Gini index, right? So what we were doing, for example, if we have attribute, suppose age is an attribute here. Age is an example attribute that we have taken, and it has 3 values. Suppose youth, senior, and middle age. So what we'll be doing in this case, we'll be taking all the subset of this particular. Yes, we'll be taking subsets of these particular attributes for attribute values. So what are the some of the subsets that you can create? Youth and middle age, then youth and senior and middle age, then youth, senior and middle age. Okay, these are the subsets that you can create. So based on these subsets, you have to create a split. For example, in this particular example that I have shared, let me increase the screen size. So in this, what I have done is I have created, so these are the splits that you can create: youth, middle age, senior, youth, middle age and senior. So for example, I am performing the split. First split I am performing by taking youth and middle age on one side and senior on the other side. And based on that, I'll be calculating the Gini index for that particular attribute. So in the subset D1 subset, what are the values that will come? Wherever the value of age is youth and middle age, that all will be in the subset D1. And wherever the value of the attribute age is senior, that will be in the attribute D2. Similarly, for D1 and D2, we'll calculate the number of samples that are positive and number of samples that are negative. So here, out of 9 samples, we have 9 samples which belong to youth and middle age. So out of this, 6 samples belong to positive class and 3 samples belong to negative class. Similarly, 5 samples belongs to senior. So we have 3 samples that belong to positive class and 2 samples that belong to negative class. You can study the data set that is given to you in order to match the calculation that is done, right? So based on that, we'll be calculating the Gini index for age. Similarly, we'll calculate the Gini index for another subset. Okay, we have 3 subsets that we can create through this particular attribute. So we'll calculate the Gini index for all the subsets, and whichever subset gives you minimum Gini impurity. Okay, whichever subset will give you minimum Gini impurity, that will be chosen to perform the split for this particular attribute. Okay, is it clear to everyone? Everyone is clear with this, right? Yes or no? Okay. So in the implementation part, so here is the implementation. First implementation that we'll be performing is, okay, first implementation that we'll be performing is based on entropy method. Okay, so we'll be utilizing scikit-learn library in order to perform the implementation, where we have already mentioned these are the attributes that are present in the data set. So these are the 4 attributes that will be taken: outlook, temperature, humidity and wind, and this is the class label that you have. Then you will be performing label encoding. So here here all the values are in the categorical form, right? It is not numerical form, so you will be performing label encoding. You can either use, here we have used normal label encoder to perform the label encoding, but you can use any other label encoder as well. For example, a one hot encoding as well to perform the label encoding part. All right, then the next step that you have to perform, these steps you have to perform up to label encoding, it is already done. So after this, you have to merge all the features to prepare a data set. So it will be prepared data set which contains all these features with the 4 features and one of the label data set, and you will split the data set into training and testing. Okay, training and testing. So you can use which of the you can use train, test, split to perform the split. Train, test, split to perform the splitting of the attributes, right? That is what you can do. Okay, sorry, splitting of the data. Then you have to define the decision tree classifier using entropy. So you have to mention, so in scikit-learn we have the function decision tree classifier. You also, I will suggest that you check in the scikit-learn library, in the scikit-learn documentation that is present online. You check all the functions that are associated with this classifier. Also check all the attributes that are present for this particular classifier. What are the attributes? For example, we had discussed in the classroom that is something called pruning of the tree. Yes, pre-pruning and post-pruning, if you call. Yes or no? We had discussed something called pre-pruning and post-pruning. So in that case, we had also discussed in pruning, we can set something like maximum depth of the tree, or maximum leaf node that a tree can take. All these things we can set. So here the data set is very small, so already we know that the tree will be very small. A small kind of tree will be created for this particular data set. But if your data set is very large, we'll also maybe after an hour we'll discuss for that also, that how you can perform pruning in the case of large data set. Okay, so first what you do, you perform the implementation for this particular data set. Also you create using this particular code. Yes, anybody's having any doubt? All right. So for this particular data set, you create the output. You can predict the output by passing certain random values that you have, or what you do, you perform the train test split. So you'll already create a testing data set, and based on that testing data set, you predict the output. Also, you measure the metrics. For example, what are the measures of metrics for classification based approach? We have accuracy. Mainly, we have accuracy. So you'll measure for accuracy, create the confusion matrix, okay, and also predict the precision and recall for this particular data set, right? That is what you can do. And later on, you can plot the particular data set using this GraphViz library that we have, where we'll be passing the features name which we have, and it should be filled. And since it will create a dot kind of file, this will be the extension dot. So we'll be converting it to PNG to view that what is the output that it is getting, what is the tree structure that you are getting. Okay. So this is the first thing that you have to do. First thing you have to do is you have to perform the implementation on this particular small data set that is given to you. In the next implementation, you have to perform the same operation, but on a different data set, which is on iris dataset. So in the iris dataset, you have four features, if you recall: petal length, petal width, sepal length, and sepal width. These are the four features that you have. But in this case, you have to perform using Gini index as a classifier. Okay, Gini index classifier, you have to perform the implementation, and you have to calculate the accuracy, model accuracy, confusion matrix you can also create, and plot the graph, right? And some of the task is given to you at the end of the exercise. Certain task is given to you in which you have to apply the same algorithm on different data sets. So for example, based on your roll numbers, you have to apply the algorithm on breast cancer data set, wine data set, digit, and I think these are the three data set on which you have to perform, right? And you have to perform based on one hot encoding and different train test split and Gini index as an attribute selection method. Also try to answer these questions by creating. First of all, you create by yourself the decision tree. Try to create by yourself the decision tree for this particular data set that is given to you using information gain, and try to answer those questions, and then check for the decision tree classifier. Okay, what is the answer that it is getting? What is the prediction that it is getting for your values, for your values that you are passing? Okay, are you clear with what you have to do in today's lab task? Is it clear to everyone for the lab 5 assignment? Yes or no? Okay, so if you face any difficulty, you can ask in the chat box, or you can unmute yourself and ask. So after 10 minutes, I'll create a Google Meet for the online students. For those, still the discussion for lab 4 is remaining. For those, I'll create a Google Meet, and there you can join, and we'll discuss for 10 minutes what you have to do in the lab 4, right? Okay. So I'll share in 5-10 minutes the meet link. Okay. created the assignment in the classroom. So you can check those files in the classroom and start with the implementation. Yes, Krishil. In one hot encoding, we are creating dummy columns. You are right. So in weather, we have three values. For example, sunny, rainy, and overcast. So for first instance, whichever value will be true. For example, in the first instance, in the data set, you have 14 tuples, and in the first instance, for example, the value is sunny. So the value will be 0, 1, 0. For example, sunny is the second one in the column. Then sunny will be claimed as 1, and the rest of will be as 0. Right? It is correct. Yes. So for online batch, I have created another Google Meet link for now. So right now, join that link. So we'll discuss for 10 minutes over there, and then you can join back here. Okay. So for all the students, right now up to 9:15, we'll perform the discussion for the online batch, and later on we'll again switch back to our lab 5 questions, lab 5 assignment, right? So okay, join that link right now. Okay, am I audible? Okay, so in the linear regression question that we have in the fourth lab assignment that you have to perform the linear regression algorithm implementation for on the given data set. So in this particular implementation, you are given a data set that is present here. This is a data set that you are given on which you have to apply the linear regression algorithm. So anyone wants to point out what are the algorithm steps in the case of linear regression? What are the steps of algorithm steps in the case of linear regression? What are the steps that you will be performing? What will be the first step that you will perform? First, you will define the model. Okay. So here, if you see, what is the first statement that you will be doing is, what is the model? Yes, separate input and output, right? Input and output that will be separate here. So here we have used four features we have used in input and one feature we are predicting in the output. That is the what is the estimated yield of apple that we are creating using the given data set. Yes, we can also also normalization of the feature is important. So in this case, if you see in this particular data set that is given to you, the data set is containing approximately good. It is not very random, right? It is some features are not very high or some features are not very low. So in this case, there is no need of normalization as of now. But in certain data set, it is possible that you might need to scale the data set. You might need to scale the features that are present with you in order to bring them in particular scale, right? Okay, so what is the first step is, first you will be defining the model. So if you see, this is a multivariate linear regression. Yes or no? This is multivariate linear regression in which we have three features here. So we have three features, temperature, rain and humidity. And so our model will be something like this. So your model will be h of x is equals to theta 0, which is the bias term, intercept term, plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. So it is also given in the file that is given to you. If you see the file that is given to you, so we can see for univariate linear regression, your formula for hypothesis was theta 0 plus theta 1 into x, where x represents the features and theta 0 and theta 1 are parameters, right? While in the case of multivariate linear regression, your linear regression model will be of this form, where theta 0 plus theta 1 x1 up to theta n xn, or whatever features you have, till that you will be creating your model. Right, so it will be in the matrix form where we have presented theta transpose into x. It is a matrix form of representation. Right? It is clear to everyone, right? So what we'll be doing first, we'll be initializing the values of parameters. Yes or no? We'll be initializing the value of parameters which we are talking here is weight and bias. In that term we are talking here. So what will be the weight? Theta 0, theta 1 and theta 2. Theta 1, theta 2 and theta 3 will be the weight that we are assigning to the features, and theta 0 is the bias that we are adding, right? So these are the terms which will be initializing first of all. Later on we'll be defining the model. So this is our model that we have created. This is the model that we have created. What will be the next step after this? After defining the model and initializing the parameters and bias, what will be the next step? Yes, loss. So we'll be estimating for each value, for each instance that we have. So we have 5 instances here. For each instance, we'll be estimating what is the predicted value based on the model that we have defined. We'll estimate what is the predicted value of the model. We'll estimate the loss of the model, right? Loss will be estimating, which is MSE loss. Okay. So in the first implementation that you have to perform implementation from scratch. That is, you have to define your own model. The model you have to define by yourself. You have to define the MSE loss function by yourself by using various libraries that we have. And you have to estimate, calculate the gradient. Okay, gradient you have to utilize. So what will be after performing the loss operation? What we'll be doing? We'll be updating the values of weights and biases. Yes or no? We'll be updating the values of weights and biases. That is what we do. And then we again estimate the prediction for the updated weights and biases. Again, estimate the loss. Again, we calculate the gradient and update the values of weight and biases. Yes or no? This is continuously happening. Yes or no? Till the loss is minimum. Yes, this is the main algorithm of linear regression. Okay, so what we'll be doing in this case is we are having in this particular day, we are going to perform the implementation using PyTorch library. Okay, which is another library that we have, scientific library that we have, which is similar to NumPy. Okay, it also has many calculation, but mostly it will be GPU efficient. That's why we'll be utilizing PyTorch. So in this particular implementation that we have, you have to utilize PyTorch library to perform the implementation. So first, your data set is in NumPy form. It is in NumPy form. So what you have to do, you have to convert them into tensor form. So when in NumPy, we are dealing with NumPy arrays. Whenever we were utilizing NumPy as a method to perform implementation, we were using the variables were of the NumPy array form, 1D array, 2D array form, right? In the case of PyTorch, we are dealing with tensors, which are actually one-dimensional, two-dimensional array itself, but they are of tensor form. The data type that you have in PyTorch is of tensor form. So first thing that you have to create is convert the inputs and targets into tensor form. Then you have to initialize the weights and biases. So if you recall, random initialization in the case of NumPy, we had a function rand_n. Yes or no? We had a function rand_n to randomly initialize the particular array, if you recall. Yes or no? So in this case also, you have to check in the PyTorch documentation, that is link that is given to you in the initial page, that if you see, there is a link given to you where you can check the documentation to see various functions that are present in the PyTorch library, right? So you can see the functions that are present in order to create random initialization. Then what you have to do is you have to define the model. Define the model that is of the form we have already discussed. What is the model that we generate? Then based on the model, you have to generate the predictions. First, you will generate the prediction. You will compare with the target. First target, that is loss, estimation of loss. Comparing with the target is estimation of loss. So you will define the MSE loss function. You will compute what is the loss that you are getting for this particular prediction, particular update values of weights and bias. Then you will compute the gradients. So in the case of PyTorch, whenever you are doing the implementation using PyTorch, we have something called backward. We have a function called backward. Okay, in this we have a function called backward, and in all the tensors that you are creating, we have a parameter, we have an attribute that is called requires grad. Okay, so if you set this particular attribute value as true, then what it will do, whenever you perform the backward, whenever you call the backward operation, backward function on the MSE loss value that you have estimated, what it will do, it will calculate the gradients of that particular attribute, gradients of that particular tensor. So for example, we have two tensors here. We have tensor of weight and we have tensor of bias. Okay, right? What are we doing? We are trying to create a model using this weights and biases. So weights is of, so we have three features here. So weight will be of three-dimensional, 1 cross 3, I think, or 3 cross 1, I'm yet not sure. 3 cross 1 weights will be that. So if you set requires grad, I'm just giving an example, equals to true for the particular tensor of weight that you have created. And if you call backward function after estimating the loss, what it will do, it will calculate the gradients for weights and biases. And using this gradients, using this W, for example, W dot grad will give you the gradient value for weight, and B dot grad will give you the gradient value for bias. Okay, using the gradients, you can update the values of weights and biases into alpha, right? This is what we are doing. So what is the updated formula of gradient descent? If you recall, what is the, using the gradient descent, what was the formula of updation? So new value is equals to old value minus alpha into slope. Yes or no? This was the weight update formula, updating formula. So what we are estimating using backward function, we are estimating this slope value for that particular attribute, particular tensor. So what are the tensors for which we want to calculate the slope value? That is weight and bias. Okay, this step is clear to everyone? Yes or no? Okay. Okay, later on after computing the gradients, you can also check this module AutoGrad to get more information on the AutoGrad, whatever it is doing. And gradient for weights and bias you have to calculate, and you have to update the values of weights and biases based on the gradient that you are obtaining, right? So this is the steps that we'll be performing. First, we'll be generating the prediction, we'll calculate the loss, we'll compute the gradient value, then we'll update the weights and biases based on the gradient value that we have obtained, and then we'll calculate the we'll perform this implementation for 100 epochs. Okay, right now you have to perform this implementation for 100 epochs. You have to keep doing this for 100 epochs. Is it clear to everyone what you have to do in the first lab practical that is given to you in the linear regression part? Yes or no? Also go through this particular implementation, particular documentation that is given to you based on gradient descent and other things to get more idea. So everyone is clear with the part? Hello? Okay, what about others? Okay, fine. In the second part that you have to do is the second implementation file that we have to utilize PyTorch built-in to perform the same implementation. PyTorch built-in operation means, so here what we'll be doing in this case, in the first file, we'll be doing it from scratch. That is, you will be defining your own loss function. You'll be defining the loss function. There is a loss function that is present using various functions that we have. For example, sum, multiply. Okay, these are the functions that we have. Based on this, you will be defining the loss function by yourself. But in the second file, you can utilize PyTorch built-in library function to perform the implementation. Okay, PyTorch built-in library function. So, for example, to implement the linear regression implementation, we have a function called NN in the neural network. In the library NN, we have a function called linear, where we will be passing, for example, we are passing 3 features as input and feature we want as output for this particular data set. In the second file, if you see, we are passing whatever number of features that we are passing is 3 features, and number of outputs that we are generating are 2. Okay, 2 values we are generating in the output. We are generating the predictions for apples as well as oranges. So what we can do, we can create using nn.linear, we can create a function, create a model where we'll be passing the values 3, 2, which will automatically by itself, it will define the weights and biases, and it will initialize the weights and biases by itself. Okay, that is what we'll do. And another thing that we can do is we can also use the optimizer Optim SGD, that is stochastic gradient descent. Okay, what is the difference between stochastic gradient descent and normal gradient descent that we have? So in normal gradient descent algorithm, if you recall, what we were doing is we were utilizing all the training examples. If you recall, we were utilizing all the training examples in order to update a parameter. Yes or no? Theta 0 is equals to theta 0 minus sum of I is equals to 1 to m, and all the values that were present here. All the training examples were being utilized in the case of stochastic gradient descent. Yes or no? Sorry, in the normal gradient descent. In the normal gradient descent algorithm, if you recall, we were utilizing all the training samples to update a particular parameter. So this can be, for example, if you have very small data set, this can be useful. Okay, this is a good method to do. But if you have very large data set, okay, large data set is present with you, for example, 10,000 or 20,000 values you have in your data set, then this will be very hard to perform computation. Yes or no? This computation will be very tough to perform. So in that case, what we'll be doing, we'll be utilizing stochastic gradient descent, which is one of the variant of gradient descent that we have. In in this stochastic gradient descent, what we do in order to update a particular parameter, we'll be randomly choosing any one training sample to update the parameter. Okay, instead of using the entire training data set that we have, we'll be randomly choosing a single training sample to update the parameter. And likewise, we'll be recursively using different training samples to update different parameters. So theta 0, theta 1, theta 2, whatever parameters we'll be having, we'll be using randomly select a single sample to update those parameters. So what will happen in this case? The Whenever we are trying to reach the global minimum, it will be very varying. The graph will be very vary a lot. It will not be very soft path to reach the particular uh, global minimum, right? But it will be much more efficient in comparison to gradient descent algorithm. Are you getting what is the difference that we are having in the case of stochastic gradient descent and normal gradient descent algorithm? Is it clear to everyone? Yes or no? Okay. Oh, all right. So in this case, we are using, instead of in the first case, what we were doing, we were using backward function to create the gradients, and then we were using these gradients to update the values of weights and biases. But in this case, we can directly use an optimizer, and in the optimizer we have stochastic gradient descent optimizer to update the values of the parameters, update the values of weight, and then again perform the predictions on the given data set that we have. So you can also use the MSE loss function that is present in the functional library of torch. You can utilize that, where you can pass the predicted value and the actual value to predict the loss. So we'll be training the model for 100 epochs, where first we'll be doing is we'll be passing the prediction, we'll be creating the predictions for the model that we have generated. We'll calculate the loss, then we'll perform the gradient descent algorithm, that is we'll be performing the backward function to calculate the gradients, and then we'll use the optimizer that is SGD to update the values of weights and biases. The optimizer dot step will update the values of weights and biases, and it will then convert those gradients into zero, so that we do not have them saved, so that our next update will have new gradient values, right? And again we'll perform this for 100 epochs. Is it clear to everyone what we are trying to do in this particular particular file? So in this case, you will be utilizing inbuilt PyTorch library function to perform the implementation. Okay, I suppose everyone is clear with this, right? And also in the end, you are given certain exercises where you have to use NumPy. You have to, without using any other library, that is TensorFlow or PyTorch, to perform the implementation. And you have to also use TensorFlow, which is also another library that we have in Python, to perform the implementation. Is it clear to everyone? Yes or no? Any doubt in both the implementation that you have to perform in the case of linear regression? Yes, you have to use this same data set. This data set that is given to you. This data set only you have to use to perform the implementation. This particular data set. Okay. Okay. So you can what you can do is maybe today you perform the implementation for decision tree classifier. So also try to perform the implementation for linear regression as well. Suppose you face any difficulty, you may ask me in the next lab that we have, or you may ask through mail itself. Mail also you can communicate. Okay. So I suppose everyone is clear with what you have to perform in today's lab implementation, right? For linear regression and as well as for decision tree classifier. Yes or no? Is everyone clear with this? Anybody is having any doubt? Okay, so you can leave the meeting and you can join that previous meeting again, and we'll talk about pruning in a short while. After some time, we'll talk about pruning. Okay, in the case of decision tree classifier.
So,
Okay, in the case of decision tree classifier, how far have you reached? Okay, implementing program. Okay, what about others? Others are also trying. Yes, yeah, yes, Priyank, yes.
I'm using that decision tree classifier function. We are calculating entropy for whole data set, but here we need to find the entropy for particular attribute. Then how to find that entropy for that particular data set? Sorry, a particular attribute.
in this particular implementation that you are asking.
Yes, ma'am.
See, I think that won't see whenever you are passing entropy, what in the scikit-learn library, what it is doing is it is using a decision tree classifier function already that is present with you, and you are passing an entropy as an criterion. Okay, you are passing entropy as in criterion to perform the implementation. So maybe you won't be able to see what it means. What it will do when it is creating a split inside the decision tree classifier, it will use entropy to perform the implementation, right? But you want to in this case you won't be able to see that what is the entropy values. Maybe you can utilize different functions to see the probability and such functions you can see. But right now I think using this particular scikit-learn library you cannot be you won't be able to see. So mostly what it will do, it will use this criterion, it will perform the operation by itself. Okay, are you getting what I'm trying? What is this the doubt that you have?
Yes, ma'am. But then how to check that our implementation is right or wrong?
Okay, you can, what you can do, you can, so for example, you have already created the decision tree that you have. So once you have created the decision tree, you can pass, what you do, you pass your own data set. For example, maybe you can pass for Outlook. You have created, or you must have already created the label encoding values, right? Label
Yes,
encoded
ma'am.
values. So if you recall, in the name bias, we're using random values, 1, 0, and 2. These values we were passing respective to the attribute that we have. So in this case also what you do, you pass the random values and you check what is the prediction that you are getting for this particular value. Whether you are getting, for example, if you created your own data set, if you are created your own decision tree by your own calculation, by your manual calculation, you must have created a decision tree that you have. So in this case, you check that what output you're getting for the manual calculation and what is the output that you're getting for this particular model that you have created using the data set. Okay, based on this, you can estimate whether it is giving you the correct predictions or not. Are you getting?
Yes, ma'am. So
Is it
in
clear?
this
Okay.
implementation, we need to find information gain or only entropy for that decision tree
No,
generation.
entropy is actually the information gain. Entropy, whatever, so entropy is actually stating that you are using information gain as a measure to perform the implementation. Are you,
Okay,
both
okay,
are the same thing. Okay, right?
okay.
So the
Yes,
route is clear, right?
yes, ma'am.
Okay, fine. Okay. What about others? Others are also anybody else having any doubt? So I wanted to mention two things before we proceed with okay before you proceed. One is the thing that I wanted to mention is pre-pruning and post-pruning in the case of decision tree classifiers. So you have already created a decision tree. Right now, your decision tree classifier that you are performing for the data set, for whatever data set, the small data set that you are performing, in that case, your decision tree will be very small, right? It won't be having much loss, much problem. But whenever you have a large data set, it is possible that your decision tree will have a much higher depth. Okay, the depth of the decision tree will be much higher. In that case, there is possibility that it is overfitting. So recall, in decision tree, the overfitting and underfitting was with respect to the depth of the tree, right? Depth of the tree, right? For example, it is possible that if your depth of the tree is very high, then it is possible that your model is overfitting your data set. Okay, it is trying to overfit your data set that you have. So one of the methods that we can do is in this case, just a minute. So one of the things that you can do in this case is pre-pruning. Okay, pre-pruning steps you can do. What is pre-pruning is you can define the maximum depth or maximum number of leaves. For example, if you see in this particular decision tree classifier that you have, so in this decision tree classifier, if you see, there are certain parameters that are present. For example, maximum depth, it is present, minimum number of samples split, minimum samples leaf. Okay, then these max leaf nodes that are supposed to be present. So these are things you can set by itself in order to perform pre-pruning in the case of decision tree classifier. Okay, pre-pruning in the case of decision tree classifier, you can set these parameters before training the model. Okay, before training the model, you can set parameters to perform the pre-pruning operation. So what you can do, I will suggest you that you take a large data set. For example, maybe you can take let's see whether I can provide you a data set or not. So what you can do, you can once you just a minute. Let me. I'll come back in 2 minutes. Okay, wait for 2 minutes. Okay, so in the chat section, I have shared a file, which is the Kaggle dataset that you have. What you can do is you download this hard disease Kaggle dataset. Okay, what you do is you perform the try to pre-prune this particular dataset. Since this dataset is very large, you will be able to see what is the changes that you can file. Like pruning. So what I'm trying to say is, you as a part of implementation, as a part of assignment, what you're supposed to do is
you try to check. For example, first you create a decision tree classifier. Okay, first decision tree classifier without mentioning all those parameter values, default parameter values. Okay, and then you perform pre-pruning. This pruning operation will involve, you will be setting certain values of the maximum load that we can have, maximum that we can have. All the parameters you set, and another decision using that, and you measure the accuracy and confusion matrix for the task you have to do in order to implementation of overfitting. In order to avoid overfitting in the using pre-pruning method. Okay, this is one implementation that you have to perform as a part of assignment. Okay, is it clear? The first part is clear to everyone? What you're supposed to do? Any doubt? Hello? Okay. Next part that you have is you have to perform post-pruning. Okay, pruning method. So if our classroom we have discussed pruning. We call this. So in this, what do? Okay, is the voice breaking? Is everyone facing this issue of is my voice breaking? Okay. Okay, a minute.
Now is it clear? The voice is coming clear, or still you're facing some break in the voice? Okay. Okay, wait for 2 minutes. Hello. Is the voice clear now? Okay, fine. All right. So what are we discussing is, if you recall, in the previous, in the lecture section, we had discussed something called cost complexity pruning. Okay. In which we were creating a subtree and we were calculating what is the accuracy. Okay, after pruning certain leaf node, we were creating a subtree and we were calculating whether the accuracy of the subtree that you have created is better than the actual tree that you have. Okay, and if it is better, then we'll keep the subtree and we'll eliminate the actual tree. Okay, we'll eliminate the actual tree, we'll keep the subtree. That is, we'll keep the pruning as it is. That is, we'll prune the leaf node in order to increase the accuracy, in order to make the accuracy better by from the actual tree that you have. Okay, that is clear to everyone. So in mathematically, if you see, whenever you are seeing in the case of a scikit-learn library, you have something called CCP alpha. Okay, there is a parameter here. If you see, in the case of decision tree classifier, there is a parameter called CCP alpha. Okay, of which if you set the value of CCP alpha, it will estimate the number of leaf nodes that is to be eliminated. Number of leaf nodes that is to be eliminated in order to achieve a subtree. Okay, so first we have to predict the value of CCP alpha, which gives us optimal value. Okay, a good subtree, whichever. So for example, so let us see through an example itself. So what is happening is, so first we have created a decision tree. For example, here we are using breast cancer data set, and in this what we are doing, we are performing train test split, and in this we have cost complexity pruning path, in which we will pass the train data set and the testing data set. Okay, the first we are doing is we are creating a model CLF of decision tree classifier, and we are using the cost complexity pruning path function to identify all the values of CCP alpha and the impurities. So what is happening is, let us see. So in the case of, if you see mathematically, what is the cost complexity pruning formula is, it is something like this, where R of alpha of the tree, that is, which is the complexity cost of this tree, okay, into R of alpha t plus alpha into t, where t is the number of leaves. Okay, t is the number of leaves. So do you recall in pessimistic pruning, in the case of pessimistic pruning, what we were doing is we were adding a penalty. Do you recall this? In the case of pessimistic pruning, we were adding a penalty to the error rate. Yes or no? If you recall. In the case of pessimistic pruning. Do you recall in the case of pessimistic pruning, what we were doing? We were adding a penalty term to the error of the, which was getting estimated. 0.5 value we were adding. Anybody recalls this? The pessimistic pruning method? Yes. So in this case also, in the cost complexity pruning, what we are doing is we are adding an alpha. We are adding a cost term to this tree. Okay. So what will happen if the alpha is very high? If the alpha value is very high, then all the leaf node will be eliminated. That is, you might assume that if the alpha value is very high, then you will be returned with a tree with only one node. That is a root node. Okay, that is the possibility. And if alpha value is very low, then what will happen? If alpha value is very low, then what will happen? If alpha value is 0, then the cost of this tree is equals to the cost of actual tree. That means no leaves will be pruned. Okay, is this clear what we are trying to do here? Let me do it clearly. So the cost of tree is equals to cost of actual tree plus alpha into t, where this is the additional cost that we are adding in the tree cost. Okay, this is the additional cost that we are adding, where we are trying to estimate the values of alpha such that the cost is minimum. Okay, the cost is minimum. The cost of the tree that we are creating is minimum. In short, the accuracy is high. Okay, so what we are doing is, for example, if you see, if alpha value is very high, then it is possible that your tree that you will be returning after performing the pruning operation will be of single node, that is only of the root node you will be returned. And if alpha value is very low, then your actual tree will be returned. That is, value is 0, then there will be no cost, additional cost that will be added. In short, you will be returned with a tree that is actually your original tree. No leaves, no leaf will be pruned. Okay, that is what will happen. So what we are trying to estimate in practical implementation that we are doing is, we are trying to estimate the values of alpha. So whatever value of alpha will be there, corresponding to it, certain number of leaf will be eliminated. Okay, certain number of leaf will be eliminated. So we are using CCP alpha. We are using this function cost complexity pruning path to estimate the values of alpha. So these are the alpha values that we have. Suppose we draw the graph. For example, let us see this graph. So for example, I'll share this particular file with you where you can see the particular implementation much more clearly. So what we are trying to do is, for example, we are drawing a graph between the number of nodes in the number of nodes and the number of and the alpha value. So you can see the graph. So with the 0 is the value of alpha, then we have maximum number of nodes. If the alpha value is keep on increasing, the number of nodes is keep on decreasing. Okay, are you getting? So that is what we are doing is we are trying to post prune. We are trying to perform the post pruning by estimating. First of all, what we'll do, we'll estimate a value of alpha, by cross validation. By cross validation, you can estimate the value of alpha, and you can also see through this graph. For example, for different values of alpha. So here you can see for different values of alpha. So what we are trying to do, train score and test score. We are trying to create train score and test score for CLF. For all the values of alpha that we have, we'll try to create the train score and test score. So you can see the accuracy is maximum before. So blue line represents the train score, and this yellow line represents the test score. So what we are trying to do is initially when the value, and we are trying to measure this based on the alpha value. So alpha value increases, the number of nodes that are being pruned will increase. Alpha value is minimum. That means the number of nodes that are pruned is minimum. Okay. So what we are trying to do, we are trying to create a graph based on number of alpha values, based on the alpha values, and we are trying to see what is the accuracy of the training data set and the accuracy of the test data set based on different values of alpha. So you can see initially the accuracy is very high. So for example, if the accuracy is very high of the tree, then it is possible the model is overfitting. Okay, it is possible that model is overfitting. So you can see that initially the value is very high, but as the alpha value keeps on increasing, that it is possible that your training accuracy is decreasing. Training accuracy is decreasing means it is possible that before the model was overfitting, now it is giving you approximately good fit. It is not trying to overfit. Maybe some classification are not getting classified correctly and so on. So initially when the model was overfitting, your test accuracy was minimum. Yes, alpha was minimum, your test accuracy was also minimum. But as you keep on increasing the alpha value, you can see that the training accuracy is decreasing, but your test accuracy is increasing. Yes or no? Can you see the what is happening in this case? So your test accuracies keep on increasing, and certain optimal values of alpha. For example, let us consider for 0.01, the value of alpha, value of training data set and testing data set is approximately good. Okay, yes, 0.0125. So it's optimal. Okay, did you measure this, or you are stating through the graph here? Janin? Okay, yes, okay, right. So you can see between the 0.1 and 0.15, you can see that the value of test data set and the training data set is giving approximately good measure. Okay, this is the accuracy that you are measuring, and you can see that it is giving a good measure. Later on, as you increase the value of alpha, that means as more number of nodes are being pruned, it is possible that the training accuracy and test accuracy both are decreasing. So you have to, so in this case, using this particular method, we are measuring the optimal values of alpha, and then we can place that alpha value to again create a decision tree to classify your particular data set. Okay, so this is one of the method through which you can calculate the optimal value of alpha. So that what is alpha mentioned here is alpha is the measure. Shows that how many number of nodes needs to be pruned. How many number of nodes needs to be pruned. So what we are trying to do is we are trying to post prune the tree using cost complexity measure. For that, we are trying to measure that what will be the value of alpha. This alpha will be a measurement that we are using. Alpha will be a hyperparameter that will be using to perform the post pruning operation. And we are trying to measure, for example, using the cost complexity pruning path, we are having different values of alpha. For this particular tree, for this particular data set, will be given a particular different values of alpha will be given to us. And based on those alpha values, what you can do, you can plot this particular graph, and you can see that what is the optimal value of alpha that I can use, so that the accuracy of the training data set as well as the testing data set is good. Are you getting what we are trying to do in this particular case? So in the same data set that I've given to you, that is the Kegel data set for heart disease, you perform these two operations. First, you perform the pre-pruning operation, that is by mentioning the maximum depth of the tree and maximum number of leaf node and so on. You perform the pre-pruning operation. Then on the same data set, you have to perform the post-pruning operation by first calculating which is the optimal value of alpha for the case, for this particular, for your data set, which is the optimal value of alpha that you can choose, and then you perform the post-pruning operation. Is it clear to everyone? Anybody is having any doubt in this case? Hello. Okay. What about others? Is it clear to everyone? Okay, okay. So Priyank, you are getting some confusion about alpha. So what is the confusion right now? You can unmute yourself and ask if you are facing any difficulty right now. Yes. Yes, Priyank.
Yes, ma'am. I am confusing in that manner that if
Hello.
means what value of alpha we want to desire for the best
Yes.
best trainings.
Okay. So are you getting what we are trying to do in this case by measuring the value of alpha or not? See, right now, try to see. In the case of, if you have studied in the classroom, we discussed one method, what is called pessimistic pruning. Okay, pessimistic pruning we measured. Okay, in that case, if you recall, we were trying to add a particular penalty. Yes or no? We were adding a particular penalty because it was measured that maybe the training error that we are getting is not the optimal error. It's not the generalization error. Okay, the generalization error means what? The error that we get on the test data set. So training error cannot be considered as a measure to estimate whether your model is performing well or not. Okay, that cannot be measured. So what we are trying to do, we are trying to add a penalty to the training error so that we can estimate that what is the actual error that the training error is might not showing. Okay, so in this case also what we are trying to do is we are, for example, if you see the mathematical representation, this is the cost of the tree. This is the cost of the tree where you are adding the cost of the actual tree plus alpha into number of leaves. So for example, you have an initial tree with these number of nodes. Okay, these number of nodes. Okay, for this you might be having certain cost. Okay, for this you might be having certain cost, and for example, this alpha mentions what? This alpha actually mentions that how many number of leaf nodes. Okay, for this you want to prune. So for example, if the alpha value is 0, then the cost will be similar. This the new cost of the tree will be actually equals to the old cost. Yes or no? The alpha value is 0. That means we are not adding any additional cost in this particular tree. That is, we are keeping the tree as it is. Now what we'll do, suppose we are pruning this particular tree. We are creating, for example, for particular values of alpha, we are pruning the particular tree. For example, this is the tree. We have eliminated 4 of the leaves and we have created a new tree. So number of leaf node is 2 now. And now we will calculate the cost of this particular tree. Cost of this tree based on the value of alpha. For example, alpha is equals to 10,000 is the value of alpha that we have. And suppose the new cost is equals to old cost plus alpha into number of leaf node. So for example, the cost of this particular tree is 20,000. Okay, 20,000. And the cost of this this cost new cost is equal to 20,000, which is probably less than the cost of this one. So what we will do, this alpha actually gives us the measurement whether the new tree that is created is actually giving better results as compared to the old tree or not. Okay, if you recall in the cost complexity pruning theory, we had discussed that we'll be creating certain subtrees, and then what we'll be doing, we'll be comparing the accuracy of this subtree with the actual tree, and we'll be checking whether the subtree is giving better results as compared to the actual tree. If it is giving better result than the actual tree, then we'll continue with the pruning operation. Otherwise, we'll stop the pruning operation. Yes or no? So in this particular graph that you can see, what are we trying to do? This alpha is actually in hyperparameter. Okay, if you recall, in the case of linear regression also, we had a hyperparameter, which is alpha. Sorry, but this all the terms are similar here. That's why you might be facing certain confusion here. So this alpha was a measurement of number of steps we can take. number of steps we can take while performing the linear regression operation. In a similar manner, this alpha is actually, whenever you are performing a practical implementation of this cost complexity pruning, this alpha is a hyperparameter that we utilizing in order to measure that how many number of leaves needs to be pruned so that your tree becomes optimal, so that your depth of the tree also decreases and your overfitting also decreases. Are you getting this? So what we are trying to, if you see this graph is actually accuracy versus alpha for training and testing data set. So before, whenever your alpha was minimum, your accuracy for the training data set was very high. That is, probably your model was overfitting. That's why it was giving a very high training accuracy. But your testing accuracy was very low. That means your model was overfitting. But as you kept on increasing the values of alpha, it actually decreased the number of leaf node. That is, it actually, if you increase the values of alpha, that means more number of leaves are being pruned. Okay, that is what it is being. That is what it is showing. So what is happening is, after pruning operation is being performed for each values of alpha, we are measuring what is the accuracy of training and what is the accuracy of testing. So if, for example, you can see for our optimal value of alpha, for example, 0.0125, this is giving a good training accuracy as well as a good training testing accuracy. So later on, we'll use this value of alpha in the CCP alpha hyperparameter to create a new decision tree classifier which is better than the actual decision tree classifier that we created without estimating, without pruning that we created. Now we'll be creating a decision tree classifier with pruning. Okay. Now is it clear, Priyank, or still any doubt? Yes, is it clear? Any doubt? If you have further, you can ask through by unmuting yourself or in the chat box. So everyone, others are also clear with this, what we are trying to achieve here. So in the implementation, in the assignment section, that you have to do is, you have to create two implementation for one for pre-pruning, operation, one for pre-pruning operation, and one for post-pruning operation. Okay, you have to create two implementation on the data set that I have given. I have given heart disease data set to you. On this data set, what you have to do, you have to perform pre-pruning operation as well as the post-pruning operation. Pre-pruning operation means max depth and etc. hyperparameter you will set in order to perform pre-pruning. While in the case of post-pruning, what you will do is, you will estimate the value of alpha for which your decision tree classifier gives better result, and perform the post-pruning operation using cost complexity pruning. Okay, so you have to create additional to whatever you have to perform these two implementation as well. Is it clear to everyone what they have to do in the lab section? Okay. All right. So I'll share this particular file in the in this classroom section for understand. Okay, I have shared with you the attendance form, and also I have shared with you the attendance form. So fill your attendance in that, and also do not share it with those who are not attending the labs. So yesterday only, I think I believe that only 100 or 106 people had attended the lecture, and the attendance responses showed around 171 people. So make sure you do not share it with those who are not attending. So I'll make another way to get the attendance in that case. So make sure that you only those who are attending the lab section are actually filling the form, right? Right. Okay. And I'll be ending the today's lab session now. So if you are facing any difficulty, you can contact through mail. I'll respond in the mail itself. If you are whatever difficulty or doubt you have, I'll respond in the mail itself. And later on in the next lab itself, also we can discuss. And yes, we can discuss in the next lab also, or we can discuss in the lecture section as well. We can spare 5 minutes and we can discuss in the lecture section, or we'll discuss in the next lab, right? So I'll be ending the meeting now. Nobody has any doubt, right? I'm stopping the meeting now, right?